Chandrasekhar, once again, thank you so much for taking time for
Thank
this
you. Thank
chat.
you. Yeah.
Really appreciate. And yeah, so maybe, it's great that our audience can listen directly from the horse's mouth about your journey, what you have been doing, and,
Yeah.
like how you have seen the tech ecosystem evolving since your journey.
Yeah, absolutely. Hey, thank you both of you for a very nice introduction, a generous introduction, I would say. Thank you for doing that, and thank you for the opportunity to help share uh, whatever I could in terms of what from our experience. When I say our, primarily it's a team effort, right? In a tech ecosystem, it's not one individual who will pull everything out. So I represent what we do as a team, and then happy to share what we have learned, mistakes that we have done, also uh, things that could be of use to someone who's wanting to make a career in this area. So thank you. So I can very quickly give you an introduction about my career, and then uh, it'll be good if we have this interactive chat based on your questions. I can take it further. Very quickly, I started roughly around 94. So in your parlance, I may be really veteran or old in terms of what you're doing. So this was, I would say, I was very fortunate to be in the area that I am in that point in time, because the computational mechanics or engineering was taking off around that time, in the sense that people were using computation for multiple purposes, but
Mhm.
to mainstream use to solve engineering, especially mechanical engineering problems, were up around the starting point where it was being introduced, right? And these, again, I worked in TCS, and we were fortunate to have GE, both aero engines and gas turbines as our customer. So firsthand, both in their plants, working with their engineers, as well as back in Mumbai, I had really good firsthand experience solving engineering problems using computation as a means, right? So if you look at there are many tools, and I should sort of do a wind back or flashback to give you the context, in the sense that today what we have as computation on a mobile phone is what we would have had uh, on a workstation using Linux, not even Linux, using Unix, which is either from HP or DEC or Silicon Graphics. These were the humongous big machines that were running,
Yeah, yeah.
yeah, uh, capable of running what we wanted to do. And computation power compared to these days, those were small, but still it was uh, very expensive. So only the automotive and aerospace customers were able to afford that kind of computation power, right? I mean, it's not in the hands of common man as it's today. So that's why I'm saying it. I was very fortunate to have had the experience to have worked with these technologies right when it was taking off. And the context is not just the technology, it is also at the cusp of people wanting to use this technology. There were leadership push in terms of using this technology. The reason for doing that is, for example, if you're doing a car crash, in order to understand the safety of the car,
Mhm.
uh, you would spend more than $1 million doing this. The reason
Correct.
for that is it's a new car, so it's not in the market, it's not produced. So you have to actually prototype, build using costly technologies, use very expensive instrumentation, and then once it's done, right? The car is crashed and gone, so you won't get back the car. So the
Mhm.
data is very vital. If you're trying to replace that with a simulation technology, you can do that 10 times, 12 times. I can make a small change in the design, run it again, small
Right.
change,
Yeah.
run it again.
Yeah.
And that gives you power to do a lot more innovation, uh, because you have this power. If you were to do only physical test and crash, you would not change 10 different things and then find out each time, spending half a year and $1 million to do that, right? So that's the context. And if you look at the culture part, as I was alluding to, uh, there were two streams of people. One who would say, yes, this can solve all problems. This is like the magic wand that can solve everything. And there are people who are very, very skeptical. They'll say, okay, I understand this, but I have to test. I have to physically crash it. Till then, I will not believe. So we had to wade through this to get the technology progressed as we go along. So those were the times that I'm talking about. Post which, when we started Axiom, which is the company that I'm CTO of, we focused on full product development. When I say full product development, from the concept where somebody is thinking, I want a new type of washing machine or a new type of vehicle or whatever, there's a concept. From the concept, you have to do creative design, which is the aesthetics, ergonomics, and all the styling part of it. Once that is done, you have to take it through the detail engineering phase downstream into prototyping and manufacturing. So this was what we have been exposed to and doing. This is early part I'm talking about, 2002 or so. When we started doing that, we were one of the earliest to be doing a full product development, because there were at that point in time many people who were service providers who were doing like 50, 100 people doing design work, same number of team doing simulation work. When I say simulation, these are math heavy simulations which help in crash test, or there are multiple tests that are done on gas turbine. There are many other tests that are done. So I'm talking about those simulations. And this is the continuum that we were trying to build within the organization. For the first 4 years, we built a lot of programs, both domestic as well as overseas. Again, it was good to have believers who believe that a small startup can do end-to-end product development, right? Again, it's not very easy for anyone to just trust your core program with somebody like us, because we had come with experience, but we have not done it outside of our context before. We all came from big organizations before, but as a startup, it was a new experience, and people trusted us to do, which was a good thing. Through this, I'll not name any of our customers for obvious reasons, but I'll talk about those contexts. Once we started doing that, we also realized that same level of technology can be used in other areas. Like, we started working with other verticals like consumer goods, packaged consumer goods, wherein deep science was not used. What we brought is the deep science that we learned in the auto and aero into verticals that were not using that level of science and engineering. That's where again, it was around the time uh, what is today called IoT was taking off. That time, the word IoT was still not coined. We were doing sensor, wireless sensor network. There are many terminologies used, but IoT as a word was still not, or an expression was still not used. This is early 2000, 2009, 2010 time frame I'm talking about. And then we had a good runway of a lot of successful programs from 2010 to 2020, where we went through a lot of evolution, both in terms of what we bring to the table in terms of IoT. Along the way, machine learning became a little more prevalent, and those technologies were really relevant for our customers. Ultimately, you may have the cutting edge technology, unless it makes sense for the problem that you're solving, it doesn't cut it. Right? So,
Exactly.
yeah.
Yeah.
So that's been the journey so far. We do a lot of work today in the, like how Aditya introduced, we do a lot of work in IoT space. We do a lot of work in machine learning, computer vision, and to some extent generative AI today. All of it, the technology is an enabler. The main thing that we are doing is solving engineering problems, mechanical, electrical, chemical, those kind of engineering problems with these as technologies to enable the solution.
You're right. So
Yeah. So
what is,
that's in short what I wanted to. I don't know if I went too far out, but I just.
I don't know, I don't think so. So I think, there has been multiple eras, that I think you have been part of. What you did then, like you said, the evolution of IoT and evolution of AI machine learning, right? So just out of curiosity, right? So what has been some of the very interesting product development you mentioned, right? That end-to-end product development, without
Correct.
mentioning the name of your clients.
Absolutely.
What are some of
Absolutely.
those products that you guys have built?
Yeah. Early on, we were more automotive focused. So you would see some of the three-wheelers that are flying on Indian roads. Core engineering was done by us at Axiom.
Oh, okay,
Uh,
that's nice.
yeah, you would see many of the uh, golf cart slash airport transport kind of electric vehicles which are running indoors.
Yeah,
You will see them in airports, zoos, all of them, which is Indian made, which is again our first program that we worked on when we started out. So
okay,
that is another. You would see a lot of those today. They are
right.
in all in-house campuses, and the best way to find out is all others are left-hand drives. Ours is the Indian only one which is on the Indian side of things.
Yeah. So tell me one thing. So when you guys started Axiom Consulting, that was just after 4 5 years of your professional journey, right? So what
Yeah,
made you,
rough.
like, how did you end up getting these, high impact projects, from your clients?
Uh, I think about 6 years into our careers, I would say, and it was similar state for all four co-founders. And
Mhm.
collectively, we had built some relationship with the customers that we had worked with. And like I said, we were definitely fortunate that they believed that outside of where we were before and when we started out, they believed that we can do that. And I would say we were fortunate in the initial stages. Yeah, we had that thought process in mind that each one of us came from one aspect of engineering. That is, I came from computational mechanics and simulation and compute kind of setup. There was another co-founder who came from creative design and mechanical engineering background. There was another person who came from the manufacturing and go to market. Uh, so we sort of complemented each other and stringed the full product life cycle. So, and we had people who said, let's do one program once there was success. It started, I wouldn't say cascade, but one after the other, slowly we started to build a portfolio of work which
Right.
were appealing to the customer.
Yeah.
And what you asked, the question is very relevant because we had to do a lot of Indian projects before we did overseas. The reason for that is around 2002, people said, and when I say people outside of India felt coding can be done here, things can be built here, but did not believe R&D and product development can be done here. I'm talking about those days. Now it's a commonplace, but
Yeah.
those days it was a struggle, definite struggle, till we built a portfolio of work.
Mhm. So how common, is this? See, software product development, it's pretty common, right? Outsourcing the software product development is pretty common, right? But R&D work of these physical products and R&D plus what do you call it, a fabrication of this products, physical products. How common is this in the market, or is it something that you guys were just doing, or there is a huge competition for this as well?
When we started out, we were not, we were fairly unique that time because there were not many people who are venturing to do. A lot of people felt we are foolish to do something like that because it's not easy to get work. and we also felt it was not easy to scale. Yeah, there is high skill in terms of people that we had to bring on board. There is the bottom line is also, I mean, the spends are also fairly high, because if you're looking at a software program or a product, the salaries are the main spend, right? Today's world, computers, they don't cost much. It's only the people cost that would bring in. There, we had to build a paint booth, for example, which is large enough. We had to have a fabrication center, clay modeling center. All of that was difficult. It was expensive. And once you invest in that, you also have to bring in enough business to justify that investment as well.
Correct.
Yeah, and you guys know it. I mean, it's not. Yeah.
Once you put in funding, or was there any external support, or you guys pooled in more money and build it on top of that?
Oh, that was a very difficult story, because when we exited and planned this, we had a term sheet for close to $1.6 million. It was right after 9/11, and that got killed. So from there on, the journey has been bootstrapped. That also meant we took much longer to scale, because we didn't do a vertical startup, as we exited with this safety in mind, thinking that we have a term sheet in hand that will translate to an investment.
And I think $1.6 million back then would have been a lot of money, right?
Yeah, 1.6 is a huge.
It's still a lot of money. So
yeah. So we had plans of starting with 40 people and then scaling from there on. Then it has to be 8, and then scale brick by brick from there on.
How big is the team now?
Now we're in the around 50.
Okay, got it. So you guys are just in Bangalore, or Axiom is anywhere else?
We are headquartered in Bangalore. We have operations in US as well as Singapore.
Got it. And what do you guys do now? Like, started from product development, but still that's the niche still you are holding on to, or you guys have moved on to something else?
We sort of pivoted multiple times. Today, it is still core product development, but the product development today is very heavy in terms of mix of mechanical, electrical, embedded electronics, a lot of software development along with AI, machine learning. So it's more a tech product development, which is again hardware driven, not pure play software tech platform. Software is an essence. Today, if you look at any product, you can't say it's one engineering stream that makes a product, right? Even car, for example, traditionally used to be a mechanically driven device, which had some electronics. Today, it's 30% software, 30% electronics, and rest is mechanical.
Yeah, but still, that electronics component is sitting on top of that mechanical component, right? So it can't work standalone. So
that I agree. I mean, if you're looking at electric vehicles, for example, right, it's a motor driver that constitutes the powertrain. For us, when we learnt our engineering, it was like there is an IC engine, there is a crankshaft that delivers power, and that delivers to the wheel. That is our upbringing. That's what I was talking about. Today, that's not there, right?
Yeah. Right.
So that's what we do today. It's tech, but product development is still core to what we do. And we also have our own product lines where we use it as a technology platform to provide services. We have one product called as Universal Instrument Interface, which is an automation platform for the lab. If you look at any factory, there will be labs, and these labs will have machines which are 30 years old as well as new. So if you enter any big plant and you see a lab as part of that plant, you'll have 30-40 machines like strength testing machines, weighing machines. There are like 20 machines that are helping you deliver quality in your product, right? That's what a lab does. Those labs today, the biggest challenge is to get data from the lab into a platform where you can do data analytics, do drive decisions based on that. You'll be very surprised to know, even today, wherein we have not introduced our platform, people are looking at the screens, writing it down, punching it to Excel, and then doing the data analytics. There are two levels of human error where you're seeing and translating and entering into Excel, right? There's potential error possibility, and there is human labor there. It's not real-time data analytics that you can drive. That's where the instrument interface speaks to machine that is 30 years old, translates that data, as well as speaks to machine that is modern, and brings them into a common platform.
Got it. So basically acts as an interface.
Exactly.
We learn the old world and the new worlds.
Both worlds, yeah.
Yeah.
It's a common interface that has hardware elements. So there's a box that gets bolted on, as well as there is a software element that provides data for the data analytics platform. The big challenge today is many of the test results are given in PDFs. So test was done, but you don't know the data inside that test. So this platform ensures that granular real-time data analytics can be performed.
That is quite interesting. So even when I listen to this, it looks very, very complex. And how did you end up achieving that, that connecting both the words and then translating into numbers and putting it into a dashboard for analytics?
So a lot of it is how we have evolved as a company. We are doing a project program with a customer. There will be our lab engineers actually performing these tests. And over a period, we learn that's a pain point, right? I mean, it's learned from that. And then we go ahead and say, okay, we build a prototype and show you this is the way you can automate. You get a customer hooked on, he says, okay, I like it. And then we start evolving the product on top of it. It's more a consulting that you do, learn from that and build a solution based on the pain points we learn from actually being embedded in it.
Right. Got it. And for this particular product, what is the industry or what is the domain, where it typically fits in?
It fits in any of the manufacturing setups where you have labs. However, we like 90% of our installations are in FMCG companies where they're doing FMCG kind of tests. The reason for that is we found that the variety of what I talked about being 30-year-old and a 2-year-old machine was very prevalent in the CPG manufacturing setups. So what that meant is they had real pain points for seeing this as a value add. So most of them were FMCG. We have other installations also, but I would say 90% of it is in FMCG space.
You guys not looking to raise funding anymore?
We are definitely looking for. There is another AI platform that we are building. I can't reveal details, but for which we are looking to raise external funding. Let's see how it goes. I mean, we have spoken to a few people because funding for a consulting thing is not an easy task. But if you carve out a product and then build a product from that, people have an appetite to.
Right, consulting based on a product,
Yeah, that is definitely something people are interested.
Correct. Right. So even now, since you're working in this product development space and that to a physical product development space, and if you look at, what I personally observed, if you look at the top tier colleges, tier 1 colleges like IITs, NITs, etc., almost 90% of these folks, or even more than that, 99% of these folks start preparing for a software development, job from the very first day of their college, right? They start doing DS Algo, start working on some projects, internships, etc. Hardly there are folks, who would actually want to go into a very core of what they're actually doing. Even someone is pursuing their BTech in, let's say, for instance, in chemical engineering or paper and pulp or even textile engineering, right? That person is also preparing for a software engineering job, right? So
Yeah.
how difficult, my question is, the follow-up question is, how difficult or challenging is this is for you guys, getting engineers who have hands-on and who are actually really passionate about uh, what they are doing.
Building.
Right, right, about
Yeah.
building those products.
Yeah. Yeah, it is difficult. I completely agree with you. It's also in a way good because whoever mentally has decided I want to be in this space are the people who are looking out for jobs like this. So
Right,
people who are thinking I'll do this work and 2 years later I'll jump to a software role are not the people who are looking at us as option.
right.
Second thing,
I
good or bad, we are not scaling at a rapid pace. Uh,
Mhm.
so it's been a steady growth in terms of the people or the headcount. So that sort of works out. We also have a fairly healthy pipeline from the interns who work with us.
Got it.
So yeah, we have 2 or 3 of them every year in the master's program doing electronics or mechanical who work with us, and not all continue there. Out of 4 or 5, we get one to build their career with us.
Got it. Got it. So just going back to the question that I just asked, do you think it's because why are people getting more fascinated towards software engineering rather than core engineering? For example, if we talk about maybe 10 years, even 20 years earlier from now, so there was more excitement or more passion towards pursuing the core engineering part, right? If someone is doing electronics, they would want to do something in electronics. If someone is doing mechanical, they would want to grab a job with Maruti or Honda and the likes of that, or go to Germany and pursue and do something big, right? Why
Yeah,
why do you think that transition is happening now?
I
Easier
feel
job, more money.
both are definitely context. I also feel there are a lot of people who are solving problems which require software engineering to solve. In the sense, if you look at many of the startups which are uh, people who are in the last year of engineering started out and then cascaded upwards, right?
Yeah, yeah.
Whichever stream of engineering, they have found a problem, solved it. When they solve it,
Mhm.
if you look at anything to solve, software is a fairly easier means to solve a problem. Uh, Given that if it's a hardware, let's say I have to use electronics to solve, I need to build a PCB. I need to design the electronics around it. I need to
Expensive, right?
fabricate
Not
it.
that easy
Eh,
to build something. Yeah, that's
Exactly.
yeah.
And I need to fabricate it. And when it fabricates, from our experience, it has to go through 3 rounds before I get a successful board. And for a
Mhm.
student, it will be much more times of experimentation before he or she gets it right.
Right.
However, if you look at a software, you can quickly put together a prototype and then iterate from there overnight, right? You need not depend on a fabrication, or you need not depend on somebody else. You have a laptop, you have an idea, you can code, you
But
can go through the iterations before you
yeah,
get to the final one.
see, if we
Yeah,
talk
you
about
are asking
software
something.
engineering, sorry, please
No,
complete.
no, no. You are saying something. Sorry.
I was saying, so if you look at software engineering from what it was 20, 30 years back, right? So I think the reason for someone to build something around software engineering is also that there has been a lot of abstraction around it. Now you really don't need to do a lot of hard work around operating systems
Actually,
or
correct,
and
correct.
stuff around it. There are a lot of platforms, frameworks, and libraries built. And even today, if you want to become a software engineer, forget about the fundamentals. You can still build a website or an app, right? It's much easier.
Correct. Much easier. Yeah, I do agree. The low code, no code platforms are like Even a lot of mechanical engineers are able to just drag drop because it's visual programming, right? Like
Right,
we
right.
said, the abstraction levels are
Yeah.
much higher.
But if you look at these folks, the same folks maybe 20 years back, they would have not survived in the industry, right?
Correct.
Because
Correct.
then you have to actually, do very core software engineering as well. So
Correct.
nowadays, software engineering is not core in its nature, right? It's very superficial and it is very much abstracted out, right? So
Correct.
my question, what I wanted to ask was, why is something similar not happening in domains like, electronics or mechanical, where you have those platforms, those frameworks, right, which people can build on top of? So
Yeah.
doing innovation becomes a lot more easier, from what it
Yeah.
is right now. Right now, if you have to do something, you have to do everything from scratch, right? So
And not necessarily. You finish, I'll talk about that.
no, that's all.
Yeah. Uh, it's definitely changed huge from, let's say, 2010 to now.
Mhm.
It started with, I think you would have heard of Raspberry Pi.
Yeah,
It's
yeah,
a open hardware foundation where they have a board where a lot of things can be plug and play, right? There's another uh, open source platform called Adreno, which is
yeah.
also a lot of plug and play. To do something similar, we would have taken 8 months to do in olden days. Uh, I say olden days of 2010, not even really old. I'm just talking 10, 12 years ago. But today, I can put together that application in a matter of week. However, if you look at a software equivalent, it'll be days, but it'll be weeks here because
Mhm.
you still have to fabricate the bridge boards that bridge from the core application to your application. Let's say you want to have a sensor to pick up, I'll just say water height to be measured. It's a very simple thing. And then switch off something, right? The board to measure the water height, you need to have a sensor that you build that can be hooked onto your Raspberry Pi for all the logic, reasoning,
Yeah.
and action. But however, the one bridge has to be built.
Mhm.
The core application is still is a huge step forward in terms of the open hardware platforms that we have today.
Mhm.
Definitely in the right direction, but not as abstracted as software.
But are these good enough or sufficient to, build an enterprise level product or build a business on top of this? Can these be used as a foundation to build businesses?
Foundation, yes, these are prototyping platforms which will get to you to a stage where you can demo, get investment, do everything, right?
Right.
Go to market, I'm not 100% convinced because there
Yes.
are many
That's
uh,
what, right.
yeah, many things that you have to take care of before you go to market. It There are many claims even within these open hardware platforms that this can be done.
Mhm.
However, from our experience, it can be done till you are making 50 boards, 100 boards, not beyond. Because beyond, you need to have a different paradigm, both in terms of cost, uh, security, uh, all other things that help
Lot of
you
parameters, yeah.
go to market, right? Why I say cost is, even though the boards look cheap, the boards can do 100 things. You want two things that you want for your application, right? Why
Mhm.
I am using that? Because it's a generic platform available to me to prototype.
Yeah.
But when you have to go to 10,000 pieces, every cent makes a difference. So I have to ensure that I only use electronics for the purpose of delivering the value.
Yeah.
I cannot use a generic board. I
So
think it's software also, it's equivalent, right? You cannot have the full. You need APIs to pull something that you want. You'll be carrying the weight of the full software in order to deliver that. It's
right,
a
but it's
similar
yeah, so
analogy.
this case you are left on the mercy of the investors, right? So
Correct.
if you don't get money, you can't experiment and you can't launch an enterprise product. In software, you can
Correct.
still
Correct.
do that, right?
Yeah.
And they see the in software still the investment will be mostly around infrastructure, right?
Correct.
Servers, etc. So you
Yeah.
can still go live, you can still test your hypothesis. You can still, experiment and see if that works, and again you can go out and ask for money here. But in this case,
it's not
you
that
just build a
straightforward.
product, right? You can't go to the market until you can, instill the same trust in the investors as well, within the investor community.
Absolutely. I agree. I mean, in the software context, with the elastic compute, the scalability that you have with the cloud computing today, you can expand as your need expands, right? Those are all not possible straightforward here, because it's again a physical manifestation that you have to build.
So, do you think this might change, or is this changing in the coming time, or even now? Is there anyone doing anything around these lines?
There are many folks who are looking at sub modules that you can plug and play. But again, it's not abstracted enough for a common man to do that. You still need, I mean, if let's say I have limited software experience, I want to do an application, there are ways that I can look up for YouTube videos and then learn enough to build prototype and get a real developer to do the further work, right?
Yeah.
This is still not that in that stage. You still need an expertise even to start the application process. Not business expertise, the electronics expertise to do that.
You're right.
Yeah. So yeah, I think people are thinking in the direction, but I would say it'll take much longer.
You're right. And I think what is also happening is, if someone is able to crack something, they are trying to build an IP around that and build a product and then encash as much they can, right? Rather than making it open for others to use. I think the value is not that much.
Yeah, absolutely. Apart from these two foundations, I have not seen anybody open it as much, both Arduino and Raspberry. Yes, there are many clones of that have come into the market open source, but still not enough. The other thing people are doing is, let's say, technology companies like Texas Instruments or Freescale or any other, they have their own modules. Let's say they have a high-tech IC that they release in the market. They build modules for specific applications. And still it's not for a common man to use, but for a good embedded engineer can be a starting point which will give them 3-6 month advantage in terms of where you start from.
Yeah, let's see. Hopefully, something should come up in this space.
Yeah.
So we have to observe.
Yeah, like IoT is a mixture of mechanical elements, electronic elements to process the mechanical signals, and then there is compute element to do decision making, right?
Right.
Electronics to compute, that is well automated. It's a smooth middleware to final dashboards. It's a well-oiled machine. The front end where it interfaces with mechanical is still the hard part.
That's what, so see, I'll give a very small instance. So even today, if I have to get the software of my car updated, it cannot happen, what do you call, over the cloud. It cannot happen on. You have to take it to the garage, ask, they'll manually plug in something, and then they manually update the software. And it kind of amuses me every time this happens. Why can't something as simple as this can be done?
I think many Tesla claims it can be done over there, but I don't know. Here, my experience has been similar to yours.
Right.
He does a factory reset.
Ola is also claiming that they are doing something similar. But even if someone is able to crack it, there is a lot of other players that are still not able to do it. Even if you look at the likes of Mercedes or BMW, for them as well, the thing is same.
I think it's not the capability, it's probably the security that is a roadblock. They have to have, if somebody can do similar work and take control of your car, it becomes difficult unless you have really very strong security to hold it, right? Anybody could hack in and take your car. Probably that's why they are looking at a physical interface rather than a over-the-air approach.
Okay. Yeah, that's looks like a more, a reasonable
Yeah,
reason for this, but yeah.
yeah. Maybe that's why it's there only in the super expensive cars today.
Correct. Right. Right. Okay. Moving to my next question. So you have seen multiple recession, multiple market downturns. You have seen the dot-com bubble. You have seen the 2008 market crash, then this COVID thing, and then the current. We are already in this recession.
Yeah.
So, what are your 2 cents, for the entrepreneurs who are seeing this for the first time, or someone like us, right? So, how do you overcome this, and how do you, uh, how do you build a stronger foundation, and come out stronger with these recessions and with these layoffs?
It's a tough thing. I mean, for us, uh, we started in the worst recession. So
Yeah,
2001 was right after the 9/11 incident.
right. That's when
And
you lost that 1.6 million
yeah,
checkers.
yeah.
Yeah.
So, and the US business is what we had banked on for our growth. Nobody from US was doing any business outside for a year because
Mhm.
they were eh, the life had come to standstill in and around US for most of the business work. Uh,
Mhm.
so, from our experience, what we did was do things that uh, probably, if I look back, we would not have done so many Indian projects if that term sheet was there. It was
Right.
well-oiled machine. You are getting
I've
business
taken bigger
work,
bets.
right?
Yeah.
So what I would look at is to look at opportunities, create opportunities, even though it may not pay as much as a full uh, in a good time. In a recession, probably you would look at doing work which is keeping you going in terms of the fires burning, as well as keep things moving, right? Dig your heels in and then look at how do you want to take it forward. Uh, 2008 was in a way okay because we had uh, businesses coming from 3-4 geographies. So reduced in one area still meant that we had business coming from Japan and Singapore, which kept us going for some time. And
Mhm.
in R&D, we do pure play R&D. Uh, I mean, if you look at who we sell to as customers, it's R&D units in most of the organizations. They get hit slightly after the real recession hits. So there was some business coming in from the annual contracts that we have had, some business coming in from that. And it was tougher than the good times. I do agree with that.
Um,
But we kept going with whatever we could do in that time to keep ourselves busy and keep the fire burning around that time. That's
okay.
what I would advise also. Yeah, it is not hunky dory always, right? You would know as well. It never is smooth. I get a month on month paycheck kind of thing, right?
Correct.
There will be ups, there will be lows. You have to ride the lows before you get to the highs.
Yeah, yeah. So I personally not withdrawn a salary for more than a year now, so I know what it looks like.
Yeah, yeah, absolutely. I completely understand.
Mhm. Sounds good. And what are, so I think I'll just wrap it up with my last question. So, what are your thoughts or what is suggestion for someone, uh, who'd want to get into the core engineering, building stuff, actually doing the core engineering part, right? And what does the future look like for them? Why should they actually get into that, and not get lured by software engineering just
Yeah.
because of, quick opportunity and quick money?
Correct. Hey, it's not just core engineering. I think I have a son who is around 18, who is in plus two, looking at what he wants to be doing, right?
Mhm.
His and his friends, all of it. I do talk about what their passion is, just follow it. Uh, if you are passionate about really building something, I don't think the software or any other distraction should distract you. Uh, if,
Mhm.
if you are in core building, you will make a career. Uh, for example, today sustainability is very hot.
Yeah.
People who invested their time and thinking 5 years back uh, did not make too much salary in the last 4 5 years, now are in huge demand, right? I mean, people are paying 2x 3x salaries to get them on board because of the experience that they've had, and that's because they invested in what they felt passionate about. It's not because they also could have been sidetracked by, I will also do software development, right? So it's all about where your passion is and what you want to be doing. And in the core engineering, I would say in the next 4 5 years, it will be huge opportunities, both in the electrification space, where a lot of uh, the traditional vehicle manufacturers are moving towards building electric vehicles, and the newer startups who are again investing a lot in the electrified uh, vehicle platforms, right? So those are definitely opportunity areas for people in the core engineering, whether it's mechanical, electrical, electronics. The second opportunity I would see is, uh, many people feel make in India is hype, but I have seen a lot of real action on the ground. And if you bring in more manufacturing into the space, it will not be manufacturing as we know of 10 years back or 5 years back. It will be really modern manufacturing approaches. And these approaches will come with even things like putting a sensor on something and tracking will be a commonplace. IoT will not be an afterthought like what we have today. It will be integral of your manufacturing process. And the people who are doing it will also be so cutting edge that it's not like 10 years back where you had to look at nuts and bolts and be at that level. So you would have a level of abstraction plus architectural thinking in manufacturing as well. So there will be multiple such opportunities for people who invest their time in core engineering, I would say.
Great, sounds good. So with this, I would like to wrap up. Sorry, you were saying something?
No.
Okay. So yeah, I was saying with this, we'll just wrap up today's chat. And thank you so much again, sir, for taking time for this. It was personally for me, it was a great, a lot of learning personally for me. So I can imagine, and I'm super sure whoever is going to, watch this is really going to get a lot of inspirations, and there's going to be a lot of learning from this.
Absolutely. I would say really thankful for you to make this opportunity and help me share whatever little experience I had with
It was
whoever
amazing.
it could be useful. Thank you as well.